Hello everyone, sorry for late because today's internet got some disconnecting for previous and everything's okay now and we can start our broadcast night. Today I would like to share some information with you about how the Raman spectroscopy drive on the highway. You know, in the past, before 2015, there are only few people know the Raman spectrometers, but in recent years, more and more people know Raman spectrometers, and they are to use the Raman spectrometers for food safety, for pharmaceutical applications, and also for the gemstone identification and biological chemicals. So today I will share all this information with you about Raman spectroscopy technologies developed. And I would like to divide today's topic into 4 important parts. Part 1 is introduce the basic knowledge of Raman spectroscopy, and secondary, part 2 I'm going to introduce 5 important application industries to you, and thirdly, I would like to introduce 5 critical performance parameters to you, and finally, but still very important, I would like to introduce 5 secret skills for product selection. So after listening to today's topic, you should have a general ideas about Raman spectroscopy. So firstly, how Raman spectroscopy is discovered. You know, an Indian scientist called Raman, he's raised a very interesting story. Why? He found that why the sea is so blue, and the blue sea is even bluer than the blue sky. And Raman conducted his research, and finally he found that the blue sea has absorbed the blue UV range, blue colors from the sun, and so the blue sea looks more bluer than the blue sky. Raman published his discoveries in paper, and he published it the first one discovered in 1928. Until that, in 1930s, Raman has won the Nobel Prize. Next, I would like to share some working principles about Raman spectroscopy. From this sketch, you can see that the molecule first absorbs the laser energies, and it will happen the energy level shifts. It will jump up to the E2 energy level, but it's an unstable state. It will return to the original energy level. Most of these phenomena called relay scattering. However, there's still some other parts that will jump up to the E2 unstable energy level. It has less energies and frequencies. It can only return to the E1 energy level, and these parts we call the stop lines. Still some field lines will jump higher to E1, higher E1 plus the HV field, and he has more energies and longer frequencies. It will bring down deeper to the E field, and this part of the photon energy level we call it anti-stop lines. So this is called anti-stop lines. After introducing the Raman spectroscopy's working principles, I would like to share some information with you about this. What the main components composed of the Raman spectrometers? Firstly, we have the narrow light-wise laser, and we have this laser has come from the fiber to this collecting lens, and collecting lens will have this form this parallel line to the focus lens. The focus lens will have the light shooting on a sample to be detected. The sample to be detected will generate the new lines called scattering, and it's a full-angle scattering. This objective lens will absorb these generating lines to here to have this reflected to here, and to here we have the long path filters and filter the rayleigh scatterings and go through the fibers onto the spectrometers. You can see from this, we have the actual pictures of the main components, and this is the Raman probe, and this is the laser, and this one is the spectrometers. And after we have all these components installed in the this filter case, like is our typical Raman spectrometers model. Secondly, we would like to share some after a signal export from a CCD, and it will go through the circuit and will go through the PC and to this platform. Finally, we can export the spectrum such as the Petri spectrum and beard. All these spectrum is the vivid features of the Raman spectrum materials, the fingerprints, and we can know these spectrums to indicate its specific materials. So, metro stations have already installed Raman spectrometers to detect hazardous liquid, and also many seafood markets use the Raman spectrometers to monitor some melatonin green. Raman spectra indicates the fingerprints of the material, so it's absolutely accurate. Its accuracy, and it can indicate the materials, the pictures, and it only takes few seconds to export the material name, so we can say it's really cool fast, and also it has a weak laser shooting on the sample, so it's a non-detective testing. Finally, it only requires charging, and you cannot need any consumable materials. It's a cheap identification. Raman spectroscopy has so many characteristics, so we have applied Raman spectrometers to the following 6 main applications. Firstly, we apply to the biomedical industries for the early cancer, and also ultra-structural change of the biological molecular, and also for the calculate components analysis. And secondary, For overseas markets, many Raman spectroscopies applied to pharmaceutical engineering used for raw materials identification and for QC raw material identification, and also used for pharmaceutical drug scan analysis, and also monitor crystallizations in process. Not only that, the third application industry is the public safety. More and more people use Raman spectrometer for the non-detective to detect drugs, narcotics, and fast detect toxic substances, and for explosives, flammable materials. And in China, the fast-growing application is food safety. Is notorious is refined battery oils. We found the Raman spectrometers are very good tools to detect it. And also, we use to detect the pesticide residues and for food additives and contaminants. Not to mention the environmental science and the gemstone identification. All these six application industries have grown rapidly in recent markets. So, what Optosky did for this rapid, fast-growing Optosky is a China national standard director for Raman spectroscopy. We have possessed the most widest Raman products ranges to provide instruments to the market. And also we have the 1064 Raman spectrometers suppliers to the market. And it's still the national exclusive and spectrometers suppliers to the market. And it's still the national exclusive. And in 2016, we launched the first super sensitive handheld Raman spectrometers to China market. And the next year, we launched the dual band Raman spectrometer that is the #1 in China and #2 in the world. We are not satisfied with the development we already have, and we are going to launch the triple band Raman spectrometer that will be the #1 in China, then the world. We are looking forward to see it, and we are also very famous for our highest temperature stability. Very famous for our highest temperature stability. After introducing so many advantages and Optosky's multi-technologies, we would also like to share some how Raman spectroscopies versus infrared spectroscopies advantages. We have introduced the Raman spectroscopies. It's about we can introduce from the principle. Infrared spectroscopies use the molecular observations spectrum, and Raman spectroscopy use molecular emission spectrum. So molecular emission is more accurate than the molecular absorptions. So we should have a general idea Raman spectroscopy is very accurate. And secondary, we can detect from the detect sample. Infrared spectroscopy, it requires prepare sample plate. So it cannot detect through glasses. It has to take out samples and it's a contact measurement. Instead, Raman spectroscopies can detect through glasses, plastic bag, crafts, and papers. It's not needed to detect samples at all, so it's a non-detect samples. So it's no need to sample pretreatment. It's easy to detect. And also, infrared spectroscopy is used to detect molecular group, and Raman spectroscopy used to detect molecular skeleton. And also, infrared spectroscopy is not good for tell the difference of isomerite. But Raman spectroscopy is very good to tell the differences of isomers, including monomer isomerite, precision isomerite, and the geometric isomers. Centennial is very good examples to tell the advantage of Raman spectroscopy over infrared spectroscopy. Centennial has so many variants, so we cannot use the infrared spectroscopy to factory tell the Centennial variants, but the Raman spectrometer can tell the Centennial new variants in few seconds. And also, infrared spectroscopy cannot detect samples diluted in water, because the water can easily effect on detection. But the Raman spectroscopy has no effect on the water. Water has no Raman peak, and in 3,400 wave numbers only appears a small curve. It cannot affect the measurement effect. And also, infrared spectroscopy requires a stricter environment condition because it's sensitive to water vapor. But the Raman spectroscopy have a good environmental suitability, and it can fit to detect at any times and any places. Finally, but not lastly, infrared spectroscopy takes a large amount of samples to build modeling for new material, and it takes many experiments to build modeling. But the Raman spectroscopy only takes 1 to 2 microgram samples is enough to build modeling, so it's fast, and it takes only few seconds to dozens of seconds to build modeling. Actually, infrared spectroscopies are complementary to Raman spectroscopy. It can obtain more complete molecular vibrational information for energy levels shift. So the question is, why Raman spectroscopies have so many advantages over infrared spectroscopies, but less and less end user use it? Actually, let's introduce our next topics. How Raman spectroscopy is driving on the highway. There are general generators to motivate it. In recent 10 years, Raman spectroscopy's application has grown 10 times. Here we say 10 times. We guess these figures can be even larger. Firstly, the Indian scientist Raman, in 1928 he discovered Raman phenomenon, and in 1930s Raman won the Nobel Prize. But till the 1960s, first laser launch for Raman spectrometers. In the past 32 years, Raman spectroscopists have developed very slow only few scientists in the lab have ever used Raman spectrometers. So everybody may ask why. That's because before lasers was invented, only monochromatic lines can be used to generate the Raman effect. But monochromatic lines is very difficult to obtain. So in the past 32 years, the Raman spectrometers only confined to few scientists and it confined to the lab. It cannot be used by most scientists to use for the scientific research. So the first laser launch, that is a very big symbolic event for the Raman spectroscopic development. And next, to the stage 3, in 1974, fresh minds discovered source. You know why Raman spectroscopy developed slow in the past 32 years? Another important factor is the weak Raman signal. So, freshmen discovered the Raman signal can enhance the Raman to millions of times. This enhanced Raman signals paved a way for the development of the Raman spectroscopic development. Not to mention till the 2009, Professor Zhong Quntian and his research group discovered shiners. Shiners have greatly lengthened the source preserve period. This discovery has published in Nature in this year. So China Technology Department has granted 87.25 million RMB to support the development of Raman spectroscopy and its application in 2010. So to sum up, is the technology innovation push the Raman spectrometer drive on the highway? Is the technology innovation push the application develop? And next, let's discuss about 5 generators to help the pave way of the Raman spectrometer. Firstly, is the first laser invention, and we still remember that in Xiamen University's chemical department, there's a Raman spectrometer that is invented in 1970s. The lasers size up to 1 cubic meters, and it size up to a table. So the lasers invention, especially the miniature size lasers and the low-cost lasers, make the industrializations possible. Secondary is the thirst enhance the Raman signals to millions of times, and the shiners, the particles have lengthened the preserved period of the source. So, shiners, the development is the third generator. The fourth generator is the sensor technology's improvement, especially the key curing technology's progress, and also the high integrated system that has also pushed the generator improve the Raman spectroscopy development. You know, All these technologies develop processors capabilities improving. Lastly but not least, is more and more research experts have joined in the development and research of Raman spectroscopy, so applications nature has matured recently. For example, in the last years, the annual events of Raman spectroscopy, over 800 Raman spectroscopy scientists have joined the event. So many experts joined this industry have rapidly grown the Raman spectroscopy and pushed the development of its application. After introducing Raman spectroscopy to fast development, we would like to introduce the Raman spectrometers. Actually, Raman spectrometers has been divided into large Raman spectrometers that Raman and Horribat. Most scientific labs already have one, but the Optoscan mainly developed miniature Raman spectrometers. We already have the Raman microscope, a full-order and high-throughput Raman spectrometers, and dual-band Raman spectrometers. We have the 4 series of portable and benchtop Raman spectrometers. That is one. And we have the miniature handheld Raman analyzer, and also not to mention the educational Raman and the exclusive Raman. We have such full range of the Raman spectrometers. So next we would like to introduce how to divide the large Raman spectrometers and miniature Raman spectrometers. In China National Standard of Raman spectrometers, there's a classification definition. We divide to the 4 classes. We have the class 1, class 2, class 3, and class 4. And we divide to class 1 for the large Raman spectrometers. There are 2 main important factors besides the large Raman spectrometer, that is the resolution and signal-to-noise ratio. Resolution should be less than 1 wave number, and the signal-to-noise ratio should be larger than 10 to 1, and obtained and monosilicon third-order peaks. And the others, class 2 to class 4, we divided to the miniature Raman spectrometers. So, why Optoscan focus on miniature Raman spectrometers? Because they are following 5 advantages. Firstly, its miniature size and is very light and easy to detect anywhere, any places. And secondly, it's a low cost. Especially because for large Raman spectroscopy, it's very expensive. Some scientists budget very limited. So our miniature Raman spectrometer provides them a chance to use Raman spectrometer to conduct research, so that it makes industrialization possible. Thirdly, like the optical components, especially grating fixed in the Raman spectrometer, it has a good repeatability, and so it's not need frequent calibration. mentioning calibration has to mention large Raman spectrometers. It requires to calibrate every day. And also, we still remember if a bachelor student wants to make an experiment, the first thing he needed to do is to learn how to calibrate wafer numbers. It has so many parameters and calibrations waiting for them to perform. So it's very complicated to use and tiresome to use the large Raman spectrometers. Our miniature Raman spectrometers not only required to make calibration once per year, so it can save lots of times for them, and it also applies to different environments. Fourthly, it's inclusively designed for the application. It's very easy to use. It sometimes takes only one pattern to finish all operations. And it has last one. It has various functions can benefit the industrialization application. This one is OptoSky ATR 3000 portable Raman analyzer. After introducing basic knowledge of Raman spectroscopy, we would like to flip to the part 2. 5 important application industry. We have 5 important application trends. They are food safety, pharmaceutical, engineering, and public safety, germ applications, and biomedical applications. Before introducing the food safety introduction, it's necessary to mention SIRS and shiners. In 1974, Freshman discovered SIRS, and it can enhance the Raman signal millions of times. But they are only limited to 3 metals of gold, silver, and copper, and with a rough surface can work out. So the problem is gold, silver, and copper. They are very easy to oxidize and lost enhance the signal. From the above picture, you can see the yellow gold particles, and in the near distances, it will generate electromagnetic signal, and it can enhance the SIRS signal. But the problem is it's easily oxidates in the air. So Professor Zhong Quntian discovered shell isolated nanoparticle enhanced the Raman spectroscopy, abbreviated shiners. Shiners make SIRS can be preserved longer than 2 years. I'd like to put it simple way. This is the gold particle, and it can easily oxidize in the air. So our question is, how can we have the SIRS effect, but we can also prevent it from the air oxidation? So Professor Tian's research team found the silica. Silica is the main ingredient of the sand, and they can have this surrounded with silica. So not only the gold particles can have the SIRS effect, it can also prevent the contact with the air. So this discovery have preserved the cells longer than 2 years. It makes the food safety applications have the potential development. This is the miniature Raman spectrometer used to apply to the food safety. And till now, Raman spectrometers can identify 130 library entries, including Sudan red, melamines, and all other libraries are pesticide residues. And also, the operation is very simple. You just need to get 1 gram and add 1 milliliter to extracting solver B, and it can use the ultrasonic extraction. It just take and just add the reagent, and you can centrifuge, get a supernet, shake it, and you can dictate results. The whole process only takes 3 to 5 minutes to finish it. It's very simple and brings the pesticide residue to result. This is a Raman spectrometer for food safety. Another example is the Raman spectrometer applied to food safety. Here is the malachite green, get from the seafood market in Xiamen University. You should be very curious, reader. Why, if you go to the seafood market, you will see the water samples used to grow seafoods. They look a little bit like blue. Where does this blue come from? Actually, this blue does not come from the UV range of the sun, and it comes from the malachite green. And here is the malachite green spectrum after adding cells. And if you get the water samples to grow groupers, you can see exactly the spectrums like malachite green. Why? Because it has added many malachite green into groupers water sample. Groupers is very expensive. If there's 1 groupers die, it will make great loss for the dealer. So, it also have to tell you story why the seafoods will die easy, because when we catch fishes or seafood from the sea, the seafood will struggle to jump, and when he jumps, the scales up there will be hurt, so it will grow many bacteria. But the malachite green is about bioactive chemicals. If you add it, the seafood will not die. It will look still vivid. It can live still. So that will attract the buyer's eyebrow to purchase it. We also like to look at the emperor fish. It also has a very small, vivid peak. It could have added malachite green, but malachite green is not good for the healthy, so we don't wish them to add malachite green. This time you can use the Raman spectrometer to detect, and in the right picture, that is the red chili powder, addicted Sudan. Its added source is 10 ppm. Next, I would like to share how Raman spectroscopy is applied to pharmaceutical engineering. You know, as we all know, pharmaceutical drugs, whatever production or purchase, it requires the 100% authentic. And in United States, FDA requires the raw materials and excipient should be 100% factory inspect. Raman spectroscopist selected for his best, convenient, fast, accurate detect results, and it's much better than infrared spectroscopy and liquid chromatogram. Not only in the United States, but also for European pharmacopoeia has included handheld Raman in the 2016, as well as online Raman spectroscopy. And now it's also worth mentioning Chinese pharmacopoeia. Before, China's pharmacopoeia has only 2 pages introduced Raman spectroscopy, but this year, in 2020, it has increased 10 times more pages to introduce it. So it will welcome the rapid development of Raman spectroscopy in pharmaceutical industry. Here, we have the Raman detect process demo. And this demo shows that you just need to press this button and it just need to wait 10 to 40 seconds. It will match the library and read the spectrum. And also, it's very fast, no need to contact the sample, and it can export the material name. It also supports a self-built library and anytime and any place. If you have a new drugs you need to detect, it can tell the detect results in a minute, in a second. Here we have export quite some drug spectrum, like sorbitol and sorbitals and sodium benzoate. All these pharmaceutical drugs spectrum is very vivid, and also it can tell the pharmaceutical name in a second. In pharmaceutical, it requires a very strong algorithm to support it. We have a deep learning and artificial intelligence. We have the most advanced HQI and confidence intervals evaluation algorithm. And now we have made a breakthrough in mixture identification. And also, breakthrough, we can tell what mixtures percentages are. All these algorithms can be realized in the handheld Raman spectrometer. And for pharmaceutical, it requires 3Q certificated. We have an IQ, PQ, and OQ. And also for the safety, we have a 21st CFR Part 11 for electronic signal. And for the audit trail, all these provide our Raman spectrometers can be matured to apply to the pharmaceutical application. Next, I would like to share the Raman spectroscopy applied to public safety. After looking at this burning bus, we still remember that experience happened in 2014 in Xiamen City. A passenger bring a petrol to the bus, and he ignites the bus, self-burning and hurts many passengers. So, if at that time we have a Raman spectrometers, we can avoid this bad accident. So nowadays, we use the Raman spectrometers to detect explosive, flammable, and hazardous liquids. It can fast detect TNT in seconds, and kerosene, petrol, diesels, alcohol, and pesticides. For flammable, explosive, and toxic substances, all very need Raman spectrometers application. We have a metro station, we have the airport, entrance and exit, we have a VIT, in the large concert, sports, and large public places. We still have the government places, court, police, jail, fire brigade. You should be quite curious why jail needs the Raman. Why jail needs to use the Raman spectrometers? Because some criminals want to kill themselves. He could bring some pesticides or toxic substances inside. If you set the entrance and exit for the Raman spectrometers, you can prevent criminals doing such stupid things. And also, you can use in the middle pictures here, you can see the police can arrest the drug dealer with the evidence of the Raman spectrometers, and you can use to the field criminal investigation to export the results immediately and use for the illegal factory check. And use the drug enforcement, customs entry and exit, armed police and border defense and fire brigade. Not to mention the fentanyl detector. It only takes few seconds to fast detect hundreds of fentanyl variants. That's a very hot topic in China. Raman spectrometers apply to public safety, and we use 1064 Raman spectrometer for the methamphetamine and ketamine, and the blue one is the ephedrine. This is the use of 1064 Raman spectrometer to export this spectrum. If you use 785 nanometers Raman spectrometers, the spectrum looks not so good. And also we share some Raman spectrometers examples for identify gemstones. Here you can see jade bracelet is very suitable for the Raman microscope to see the pictures here, and also you have this jade bracelet too. And also for diamond, if you want to know if the diamond is a fake and true, you just need to use the Raman spectrometers to show. And if it's a true diamond, it has only a vivid peak, like this one. If it's a fake one, this one is a fake one, you can also have a report here. Have not only one peak. We use the handheld Raman for detect gemstone bracelet. Next, we would like to talk about how Raman spectrometers apply to biomedical application. You see, some companies have announced non-invasive blood glucose wristband, and he can monitor the different concentrations of blood glucose and can synchronize in the cell phone screen. And after the Samsung, the Apple also have the research teams working on it. And besides the C8, another two companies also have developed finished products for the non-invasive blood glucose. This is a very important application, so patients are not need to seek blood at all. It just need to wear a wristband. And also there are some people report Raman spectroscopy applied to detect cancer. And this is the cancer spectrum, lung cancer spectrum, and healthy person's spectrum. And it is reported that healthy person Raman peak is in 781 wave number, and with cancer is here. It has the 7 wave numbers shift. This reported this accuracy is very high. It has 96.9%. But we haven't verified it. But it can have a testimony that Raman spectroscopy applied to lung cancer application. And also Raman spectroscopy applied to detect skin cancer. The green spectrum is the normal spectrum, normal healthy spectrum, and the red one is the early cancer, and the black one is the cancer patient spectrum. And also Raman laser can focus on different lengths of the skin. It can have the different spectrum results. And Raman also endoscopy technologies to detect cancers. It has the normal Raman spectroscopy, and it has the cancer Raman spectroscopy. It can use to detect lung cancer. It has a gastric cancer and a cardiac cancer, and also esophagus cancers. All this can be seen from this spectrum picture. And also scientists use Raman spectrometers to detect pink eyes business causes. They say that there are mainly 4 disease causes the pink eyes. That is the bacterial, and the virus, and the fungi, and the mold. So this is the spectrum of bacterial keratitis tear spectrum. And if you know it's caused by bacteria, the doctors can prescribe the antibiotic medicine to you. And if it's caused by virus, keratitis tear, the spectrum looks this way. And also fungi keratitis tear and mite branchitis tear. Let's move to the part 3. We'd like to introduce 5 critical performance index. There are 5 important parameters that design the Raman spectrometer's performances. That is the spectral range. Secondary is the resolution. The third one is the sensitivity. The fourth one is the signal to noise ratio. The last one is the reliability. All these 5 factors can decide the performance of Raman spectrometers. Firstly, let's show you how the Raman spectral range differences can tell us. Here, you have the ATR 3110, and we have a spectral range from 200 to 2700 wave number, and the spectrum is the external. If you can only cover to 2700, the spectrum looks like this way. However, if you have a wider spectrum to 4300 wave numbers, it will have a more spectrum. Here. Yeah, if the narrow wave spectral range, you cannot see this peak, but in a wider spectral range, it shows this peak features. So the wider peaks are also useful. And also we would like to share what the spectral range and the relationship with resolution. Spectral range and resolution are paradox. The wider the spectral range, the poorer the resolution, and the narrower spectral range, the better resolution. For example, 200 to 2700 spectral range, the resolution 6 wave number is better. With resolution value is smaller, the better. And if you have a 200 to 4300, the resolution is 10. So that is poorer. So what spectral range is all depends. It depends on grating lines. The narrow spectral range, it uses the less. It uses less grating line. We use the 600 grating lines for the narrow spectral range, and we should have 12,000 grating lines for the wider. So the more grating line, here we make a mistake here. Here is the narrow spectral range. It should use the more grating line, and for the wider spectral range, you have less grating lines, and also from the spectra you can review the resolution information. How resolution revealed the rich information of the spectrum. If we enlarge this peak to this one, you can tell this have a 2 peak here, and the wavelength resolution is less than 6, you can tell this 2 peak. If resolution is larger than 6 wave numbers, you cannot tell this 2 peak. So the smaller the resolution value, the better. So it can tell the more vivid peak, and the higher performances. It can reveal richer spectral information. And so we will talk about the test method for resolution. What's the test method for resolution? usually use the United States standard ASTM. So we have a calcium carbonate test. We obtain the 4 watts half maximum FWHN and in the peak of 1085 wave numbers. And we use the formula resolution is FWHN divide 0.86684 divide 1.0209. And also we can accept calcium carbonate test. We can use elementary lamp for test. We have argon, xenon, and krypton lamp to use to detect the resolution of the resolution. And also introduce the China standard, literally elementary lamp test. We divide it to the UV range. You use the halogen lamp, and we have visible one with near lamp, and we have a near infrared. Use the argon lamp. So we use this elementary lamp to calibrate to test the resolution. So the resolution is so important. AutoStar has researched over a year to publish the 5th generation Raman spectrometers resolution, and the new generation of Raman spectrometers resolution will enhance to 3.8 wave number. That's the very high standards in the world. So, what are the main factors besides the Raman spectrometers resolution? We still use these pictures. The main factor is the laser line width. If the laser line width is ideal, resolution is mainly dependent on the spectrometer. So, what are the main factors besides the spectral resolution? Firstly is the slit size. The wider the slit size, the poorer the resolution, the higher the sensitivity. Usually we use the 50 micrometers slit size. And if you want the 25 nano slit size, the resolution will be better, but the sensitivity will be lower. And also we have the grating lines. So grating lines, the more grating lines, as we have mentioned, the more grating lines, the narrower spectral range, and the higher the resolution. And the less the grating line, the wider the spectral range, and the better the resolution. And thirdly is the sensor pixels. The higher the pixel size, the higher the resolution. And AutoSky provides maximum 4,096 pixels sensors, so we have very high resolution range. And still, optical path designs can also effect on the resolution. We have the cross-CT and M-shaped CT. So, let's introduce what is cross-CT. Cross-CT is the incident light goes through here, and it will collimating mirror to form the parallel to light, and it will go through grating, and grating will shoot on the focus mirror, and the focus mirror will shoot on the detector. This is the cross-CT. Cross-CT, it has a compact size, and but the sensitivity is better. Many opto-sky spectrometers use this design. And let's see the N-shaped CT optical path design. Firstly, there's an incident light goes through here to collimating mirror, and it forms the parallel light to go to the grating to reflect to the focus mirror and to the detector. This is unfolded also N-shaped CT. It has a larger size, but it has a higher resolution and a better straight line. It's very good for our Raman spectrometers. So, opto-sky use 3. The third number is 3 to indicate is the M-shaped Raman. The spectrometer use the M-shaped design. So all the optical paths can also decide the resolution. Next, we would like to introduce the test method for sensitivity and signal-to-noise ratio. Large Raman spectrometers usually use the silicon wafer to calibrate the second and third peak intensity. However, miniature Raman spectrometers lacking auxiliary focus microscope system and personal skills take more effect on static measurement. So we usually use liquid to adjust focus, measurements to adjust the focus. Here are some opto-site attachments like liquid sample cells and solid and powder sample cells. And also we have precision probe holders. Next, we would like to introduce how to detect sensitivity of miniature Raman spectrometer. Firstly, we get some liquid samples, say acetonitrile. Alcohol is also okay. You can test the skills metal list for the liquid detect. Secondly, you set the testing condition like laser power, integration times, and average times. And thirdly, we have the focus point, and you can start to scan spectrum. Don't forget for the baseline correction to remove the fluorescence curve. Finally, we can obtain a certain peak intensity to compare it, such as we can obtain the acetonitrile in 918 wave numbers to do it. And also, there are some effective methods that can improve the sensitivities. As the manufacturers, we usually can increase the collecting light angle of this one collecting light angle, and also we can improve because it has many transactions. We can improve the transitional efficiency and coupler efficiency to improve the sensitivity and improve the spectrometer's optical efficiency. So what main factors determine the Raman spectrometer's sensitivity? Sensitivity is in proportion to the correcting light angles, and it also in proportion with the probe transmission function, and also with the coupler efficiency. Coupler efficiency is very difficult to improve because if sometimes if you have a 70 to 80% efficiency, that's already very good one. And not to mention the fiber efficiency is already very mature in fiber manufacturing. The last one is also very important one, is the spectrometer's efficiency. So, next we are going to explain what the main factors that determine spectrometer sensitivity. Efficient spectrometers is decided by the slit width, lens refractions, and grating efficiency, and also the sensor's cotton efficiency. See from this formula, we see that there are many factors that decide the Raman spectrometer's sensitivity. Not only listed in here, there are still many other factors that can determine the sensitivities of the Raman spectrometers. Sensitivities, how we can dictate. So we know sensitivities. So next, what's the common test methods used to dictate the sensitivity? The common test method is incorrect, I have to confess. But there are so many users use it, and it can dictate some performances. So I also introduced here. Common test method. Firstly, you have a measure a spectrum and obtain the peak height 918, such as the 918, and you obtain noise RMS value. Use the peak height signal to divide to the noise RMS level. You can get a signal to noise ratio. So why is the wrong method but frequently used by the user? Because it still can reflect some qualitative performances. And it's easy. You only take a spectrum, it can know the result. And it can vividly confront the person's intuitive feeling. If the peak height, the signal is high and the noise level is less, we know this performance is good. However, if the peak height is low, but the noise is very small, very big, we know the performance is not good. So it can really tell the performances. And these parameters also relate to the machine learning to identify spectrum. So still many people use this way to dictate the signal to noise rate, to know the signal to noise ratio. So what's the correct methods for the signal to noise ratio? Here we would like to introduce that firstly, it's needed to perform continuous acquisition, say 100 times, over 100 times. So firstly, you will export over 100 spectrums, and you obtain the peak here to line it in line to this one. Then you get the average number, and then you can obtain the mean sequence error noise value. We use this peak average divided to the noise NSE, so we can calculate the signal to noise ratio. This test method also have a detailed introduction in Professor Tang from paper to know details. What effective means can improve the signal-to-noise ratio? As a manufacturer, we mainly focus on three important steps. Firstly, it's needed to improve optical efficiency so we can improve the instrument sensitivity. Secondly, you can reduce the noise. You can reduce the sensor's noise, the laser's noise, and the background noise. And this is the manufacturer focus on. We can reduce amplifiers noise and the ADC's noise and also noise of the one device F and other noises. And other noises can reduce. Finally, you can select suitable dictator. So this is our factory can do to increase the signal-to-noise ratio. As a user, what we can do? We can firstly find the right focus point. The right focus points can make you have to have a better signal, and you can improve the average time. Also, you can enhance excitation power, but excitation powers should limited to which cannot damage the samples. Whether manufacturer's effective means or user's effective means can improve the signal-to-noise ratio. Here we would like to introduce a key index of instrument reliability. As we have already mentioned before that optosky very good and instrument reliability. How can we approve you that our instrument reliability are good? Firstly, we have the peak shift change with temperatures experiment, and our temperature stabilities are very good with the wave number, intensity, and laser wavelengths. And intensity stability change with the temperatures. Our intensity change rate, stability change rate is only 0.37%. So that is very high in the industry. And also, we performed 24-hour runtime stability. And our variance is only 39.89. Change rate is only 0.14%. So, after all these tests, we can say optosky Raman spectral instrument is very reliable. After saying our reliable instruments, we also need to introduce what are key factors that can improve Raman spectrometer's reliability. Firstly, we use the spectrometer's design. Firstly, the design. Our design is a sandwich structure. It separates the optical paths and the circuit paths to these two paths. And we fixed all these optical components to the medical platform. And also we separated the circuit paths. They will generate heated volatile matters pollute the optical components. So we use the metal divided room to divide the optical paths and circuit paths. And also we use very good material and wood. And also we have the most advanced craft, because one of our engineers have been designing aerospace spectrometers, so we can have some very high class introduced in our spectrometer. And also we have an aging. To improve the Raman spectrometer's reliability. For mentioning, referring to reliability, it also need to mention the inspection tools. We have a temperature to dictate. The temperature cycle curves can from -10 to 45 degrees, and we perform continuously 48 hours, and total we have 12 cycles. And after performing 3 temperature cycles, we can note our temperature reliability is very good. And also we have electromagnetic compatibility to perform here. And also we have vibrational resistance platform. All our reliability inspections are performed forward QC systems of Angela. Part 4, and finally, we would like to share the 5 secret skills for product selection. So what are 5 secret selection skills? Firstly, we use the 5 keywords. Firstly is application. What's the application? If the user wants to purchase a Raman spectrometer, it's very important that what do you use for? So that according to your application, we can know whether it's used to use the Raman spectroscopy, or we can use the portable Raman spectrometer, or use the handheld Raman spectroscopy. And if we note one material you want to detect, we can know which wavelength is most suitable for your application. It's good to use the 1064 or 785 for the most popular wavelength for its high performance to price ratio. And we also need to know the wave number, because we already mentioned wave number can, while the wave number can also have reveal some spectral information, and also resolution and sensitive to noise ratio. Secondly, we need to see what brand to buy. Firstly, you should ask, is it a well-established brand? So you can ask, is it an expert in the industry? Yeah, Spectroscopy is the Raman spectroscopic expert in the industry. And you can also ask if it has a good reputation, because you can ask the purchaser, ask other buyers, how the Raman spectrometers used. Is it good to use? And also you need to select a rich experienced manufacturer, such we have 20 years experience. And also you should choose a full range of Raman spectrometer series. All these 4 factors contribute to you to select a well-established brand. So Spectroscopy is a well-established brand in Raman spectrometers. And also, you can ask the users to detect the performances of the parameters by themselves. Send samples to the manufacturer to export spectrum. Is it the spectrum you required? And fourth one is the service. If it has a good service before sales, in sales, and after sales, can you contact the local distributors to know what's the service? And finally is the price. Price, we can know is the best performance to price ratio. If the price is too low, it takes a risk of the poorer performances and it could have the less services. So we should compare the performances and prices, and you can have the best price range for you. And secondary, we would like to we mentioned that we need to dictate how to select wavelength ranges. So you could ask how to select wavelength ranges, because we already mentioned that wavelengths selection is important for your application. So we have the 4 wavelengths from 266 nanometers to 1064 nanometers, and they are still two different applications, such as the most popular one is the 785. This because it has the balanced performances and is the most economical due to most samples. The single note is not too high, it's not too low, it's very suitable. And also we have the 532 nanometers wavelengths. Users usually use this to dictate graphings, biomedical samples, and virus, and because it has the. And also we have the 633 nanometers, very good for metallic oxide. Not to mention 1064 nanometers wavelengths have many advantages. We will have another big broadcast about it later. It's very good for biological tissue, cell, bacterial, field, and high fluorescence samples. But we also have the A30 nanometer can use for non-invasive glucose, and we have the 266 nanometers. It also can use to dictate high fluorescence samples. Why? Because it can difference the Raman signal from the fluorescence signal, and we use an algorithm to remove the fluorescence signal, so we can have the Raman signal. And also 266 nanometers wavelengths have the highest signal. His signal is 16 times higher than the 532. That is 16 times from 1064. Here's an example of user optoscoped Raman spectrometers dictate graphing, and this spectrum result is provided by the Professor Lee in Xiamen University. They compared the X-chloride class and with our miniature Raman spectrometers. Although large Raman spectrometers can dictate the graphing, our miniature Raman spectrometers can also export very good spectrum, so it can vividly tell our Raman spectrometers is. And before we have talked about the how to select right models for you. So next we would like to share with you what the Optoskype, a full range of Raman spectrometers family. We have this family map. You can see from the right corner, we have an educational Raman spectrometer. We have a full range of the portable Raman spectrometer. And we have a handheld Raman spectrometer. We have many models here. And we also have an online Raman spectrometer. Until the higher performances. And we also have the high throughput Raman spectrometers. We have the microscope Raman spectrometers. We have such a full range of Raman spectrometers from bottom to the top. Whatever your applications needed, you just need to give me, we can recommend the right models for you. And also, we also want to introduce our next generation Raman microscope. This Raman microscope is performances we're testimony Optoskype Mighty, and that's predicted new product launch. And next, we also make comparisons because BW Tech is already a familiar brand for the overseas market. So how can we vividly show you our performances? So we want to compare with the BW Tech iRaman Plus to let you have a general idea of how the Optoskype portable Raman's performances. If you can see clearly, BW Tech iRaman Plus performances is very similar to the Optoskype ATR3110PS. You can see from the wave ranges, it's very similar. But the resolution iPlus is much better than the Optoskype. But our sensitivity is much better than the BW Tech. And we can cool down to the -5 degrees. And we also have the -15. But he is only -2. And our laser power is larger. It's only 300. And integration time is similar. And dynamic range is also very similar. From this comparison, you can know that Optoskype has a higher sensitivity but a poorer resolution. But don't worry, Optoskype, the new generation of Raman spectrometers, have already made a breakthrough of resolution. Our resolution, we keep the current high sensitivity. We can greatly improve the resolution to below 0.5 wave numbers. And these new Raman spectrometers were upgraded in our ATR3110PS. That indicates Optoskype portable Raman spectrometers can be quite competitive to BW Tech iRaman Plus. And next, we would like to introduced 1064 nanometers Raman spectrometers. Here, we also compared with the familiar BWTech iRaman X, and you can see that optosite ATR3110 1064 is very similar to the iRaman X, so whatever the spectral ranges, and also it's very similar. The resolution is less, but it doesn't matter. Others, we have the higher laser power. And our light width is better. And we also have an 18-bit ADC, and BWTech has 16-bit. Ours is better. And we also have the integration time 10 milliseconds and to 10 minutes is longer than BWTech X. And our sensitivity is still very high. So we can see from here that as the exclusive 1064 Raman spectrometers manufacturers, our performance is also very competitive. And also we make some introductions of 785 handheld Raman spectrometers, optosite ATR65000, that is Nova winners. We have the widest spectral ranges and the very best resolution. And we have laser power here. Laser power can be to the 500 compared to others. And our resolution compared to others is the widest. The laser power, ours is also very good. The most important is the major speed. It uses free space technology, so the laser speed just takes 3 seconds. It's the most fastest and is also verified by the many users. And our user friendly is very good. We have the biggest screen and use the Android system. And we have 2 cameras. And our library is very much. And our battery time, they also run. And all this comparison shows that optosite handheld Raman performances can be competitive to the thermal TrueScan, TrueNAP, and BWTech very popular NanoRam and Smith. All these can show how our Raman spectrometers performances looks like. And also, it's necessary to mention 1064 handheld Raman system, because till now, it's still only 3 manufacturers in the world can produce the 1064 handheld Raman. One is the Regato, and the another one is the BWTech. The third one is the optosite. Optosite ATR6600 is a very good instrument. Has been verified. It has the similar spectral ranges and the similar resolution. We have the large laser power, and our major speed is the fastest one. And also user friendly, and the camera can scan the barcode. Our library is also very complete, and our batteries can use the longest 6 hours. And in the market, many users complained about BWTech. His batteries can BWTech, his instruments can be very hot after a wired detect measurement, but ours heat distinctions do the better. And also we have work temperatures and the smallest, the compact size, our size and weight is the best. And next we also shape our ATR 8300, that's the autofocus, auto-scanned Raman microscope with a mapping. This is still the only one in the world with a mapping in the miniature Raman microscope. We have the 5 megapixels imaging, and we have a real-time autofocus, so you can detect uneven samples and form the picture. And we have the 2D scan, can have the move ranges and move resolution 0.1 micrometers. We have an optional 3 objective lens. High sensitivities, we have the Raman spectrometers. It can deep cooled backsync CCD. We have a high reliable design without moving parts. No need frequent calibration and suit to various environments. This Raman microscope is very popular in China. Every year we sold dozens of this instrument, sets of instruments to the university. And also, here's some spectrums use our Raman spectroscopies for research. And this is use Raman spectroscopies to detect the cell metabolisms. And we have different wavelengths. Right here, you can see that. Okay, great. So today my sharing is here. We would like to welcome you to ask us questions. So we have questions. Maybe instruments that detect ceramics. Yes. Our instruments can have detecting ceramics, and we have data in our library. You can contact me later for this more information. Second question is, can Raman spectroscopy be used to detect the coronavirus, COVID-19? Yes. We have already professors research use the Raman spectrometers to research virus, and this research is still in process. The professors haven't published this yet. We will follow this and send you and share more details with you. But it can be. The third question is, how can the resolution of Raman spectroscopy be better, and yet the sensitivity is low? For a better Raman spectroscopy working efficiency, which one has to be high? Is it a good resolution or high sensitivity? So, as we have already mentioned in our PPT that the resolution depends on the optical design, spectrometer's design. So, spectrometer's design is the most important one. And also, spectrometer's resolution is decided by the slit size, like a pixel size, and also we have here and the pixel size, and also maybe optical path design, and the transmission transmissions losses, and also many lists can be done to a very good resolution Raman spectroscopy. Okay, and for more questions, can you contact us later after the live broadcast, and I will answer you more details. Okay, thank you for sharing time with me, and see you next time. Bye bye.